Welcome to Creative World. In this video, we will solve control systems problem. Problem states that find the range of k for closed loop stability of a unity feedback system with open loop transfer function gs is equal to k into s plus 1 divided by s into s plus 2 multiplied by s plus 3. Block diagram for this particular problem will be this. In this problem, it is not highlighted either the system is negative feedback or positive feedback. So I am assuming that the system is negative feedback system. Open loop transfer function of this system is provided here. Forward path gain g of s of this system will be equal to the open loop transfer function of the system because it is a unity feedback system. And we know that the open loop transfer function of any system is equal to the forward path gain g of s multiplied by feedback gain h of s. In case of unity feedback system, the h of s is 1. So the forward path gain of the system is equal to the open loop transfer function of the system. That's why we have taken here the open loop transfer function of the system as forward path gain. Now move towards the solution of the problem. First of all, we will calculate the transfer function of this negative unity feedback system. This is a generic negative feedback system. Transfer function of this negative feedback system is calculated using this equation. Transfer function is equal to forward path gain divided by 1 plus forward path gain g multiplied by feedback gain h. But in the case of unity feedback system, the h will become 1 and transfer function will be calculated using this formula. Forward path gain divided by 1 plus forward path gain. Now in order to calculate the transfer function of this particular negative unity feedback system, we have to place the value of forward path gain g of s inside this formula. So the transfer function equation for this system will be this. Solve this equation to calculate the transfer function of this system. Multiply this denominator value with 1 and it will become s into s plus 2 multiplied by s plus 3 plus k into s plus 1 divided by s into s plus 2 multiplied by s plus 3. These denominator values are same, so both of these will be cancelled out with each other and the transfer function equation will become k into s plus 1 divided by s square plus 2s into s plus 3 plus ks plus k. Here in denominator s is multiplied with s plus 2 and k is multiplied with s plus 1. Now multiply s square plus 2s with s plus 3 and the transfer function equation will become k into s plus 1 divided by s cube plus 2s square plus 3s square plus 6s plus ks plus k. Up to this point we have calculated the transfer function of this system. It includes the variable k and we are interested to calculate its value so that the system should be stable. We will use Routh Hurwitz criteria to calculate the range of k for the stability of this closed loop system. First we will make Routh array and Routh array will start from s cube. The Routh array will be implemented only on denominator and the highest order of s in denominator is s cube. So the Routh array will start from s cube and it will decrease up to s0. Now place values inside this Routh array from this denominator. Coefficients with s odd power will be placed inside this row and coefficients with s even power will be placed inside this row. So first entry inside this array will be 1 because s cube have 1 coefficient along with it. Second entry will be 6 plus k and it is placed inside this row because it is with s power 1 and 1 is odd. So it is along with the s that have odd power. Similarly 5 will be placed below inside this row because it is along with s even power 2 and k will be also placed here inside this row because it is along with 1, and 1 can be written as s power 0, and 0 is an even number, so the power of s is even. That's why this k is taken inside this row. We have placed all the entries inside this row. The remaining two entries will be calculated using these values. In order to calculate this entry, we have to multiply this minus multiply this and divided by this value. So the value of this upcoming entry will be 5 multiplied by 6 plus k. It will become 30 plus 5k minus k multiplied by 1. It will become minus k and divided by this value 5. Solve it to calculate value. It will become 30 plus 4k divided by 5, and this will become next entry 30 plus 4k divided by 5. Now the next entry is S0. So the coefficient of S0 is k, so we can place k here. We can also calculate the value of this entry by this method. For that purpose, an entry should be available here also. In this case, it will be 0. Now multiply these together and these together and divide by this value. Product of 0 and 5 will become 0. The only values that will left is k multiplied by 30 plus 4k divided by 5 and divide by this value 30 plus 4k divided by 5. Now these two will cancel out with each other and only k is left that we already have taken. Now in order to make system stable, the first column of Routh array should always be positive or there should be no sign change. From this statement we can say that this k and this value 30 plus 4k divided by 5 should be greater than 0. So with the help of this statement we can calculate the values of k. 30 plus 4k divided by 5 should be greater than 0. This 5 will multiply with 0 and it will become 0. Only the value will left 30 plus 4k should be greater than 0. Now place this 30 on right hand side, it will become minus 30. 4k should be greater than minus 30. Now in order to calculate the value of k, we will divide on both sides with 4. It will become k should be greater than minus 30 divided by 4, and it can be written as k should be greater than minus 15 divided by 2. We have calculated the value of k for this particular entry. Now we will calculate the value of k for this entry. And for this entry, k should be greater than 0. So now we have two ranges of k. One is k should be greater than minus 15 divided by 2, and other one is k should be greater than 0. If we take this range of k, in this case this entry will become positive but it will become negative. So it is violating the rule. That's why we will take this range of k. In this case both entries will remain always positive. So the range of k for the stability of this closed loop system is k should be always greater than 0. So this was negative unity feedback system problem of control systems. Thank you. See you again in next video.